Hi, my name is Sanjeev Thurgam, and this is my goal points video for Project Zero for the Cs61B course here at UC Berkeley. In this project, we essentially created, after all things, an animation that displays a bunch of planets from a given file rotating in a system. So I can go ahead and run the program, and I can talk you through my coding process as well as what I did for the goal points portion of this. So as you can see, we have this animation that shows planets as well as a spaceship, which we'll talk about later. But essentially, the way this works is we're given a file with certain values for planets, essentially coordinates of like an X and Y in a system. Or like on a grid, as well as their initial velocities in their respective X and Y directions, along with their mass and a name that corresponds to the file path to the image in your computer. So what the program does is it essentially uses principles of gravity and physics to calculate like the mathematical calculations that work to calculate what the net force might be exerted on an object given the other objects in a system relation to it in terms of the other objects' respective own x velocity, y velocity, position, etc., etc. So what my program does is in one specific time step, it essentially takes each of those objects in the system and calculates its respective net force based on all the other objects in the system and their respective forces, and as a result, combined with the mass, the respective gravity they exert on others. Looks like the program has ended, so I'll just run it again to display. So what this program does in order to achieve the animation part of things is it does these steps at a high amount, like per second, like thousands of times. So essentially it's calculating this multiple times and displaying to us those movements continually updated, which it does so fast it looks like animation. So for the goal point section of my project, what I did was, on top of that basic implementation of implementing a bunch of systems or a bunch of objects in a system that can interact with each other and gravitationally influence each other, I implemented a spaceship that you can control with your WASD keys. So I'll go ahead and press W now. You can see it moves around. And if I just let it go, you'll see that now its orbit has been updated. So it's not different from what it originally was. And if I move it again, the orbit will now change because it's closer to the sun. It moves around like that. I added some extra features, like for example, being able to speed the ship up. So if I press N on my keyboard, just standing for like nitrous, I guess, I don't really know what else key to press. If I press it, you can see how I'm moving around now. If I press N, I can move around a lot faster. And then that can happen. So I noticed that can occasionally happen where my ship gets too close to the sun or into a gravitational path that can no longer be recovered. And I wanted to be able to get the ship to come back. So I implemented a reset. So if I press R on my keyboard, program stops. Let me go ahead and run it again. This is just based on the amount of time I have for the program to run. So reset it. So I'll go ahead and do that again, where I speed it up, go to the sun, it goes off the screen, right? And I don't think I'll be able to recover it. It's moving too fast for me to have the speed to get it back. So if I press R on my keyboard, it'll essentially reset the spaceship back to where its original starting position was, along with the same original velocity, everything. So like I said, if it goes off, I can reset and I get it back. I can keep moving around. If I want to get back to my original speed, I can press B for brake, and that goes back to my original slower movement speed. And I can press N again, nitrous speed back up. I also wanted to see, like, if I do end up going off like so, I could press H for hyperspeed, and that allows me to move super fast. So if I reset it and show you guys the speed now, this is like hyperspeed. It's supposed to be really fast. So if I do like fly off, let me try to get it fly. Oh, that's too fast. But if I get it to fly off at a decent angle like that, you can see I can move back like in the screen. So it's like that. And again, if I press brake, it'll move me back to my original speed. And I can select back to nitrous or hyperspeed, back to nitrous or back to braking, and then reset again back to my original speed. So yeah, I thought the other thing is, obviously, as I hope you've seen, is that the spaceship is not only movable, but is constrained to the gravitational pull of these other planets. But yeah, that's what I implemented for my goal points. I hope you enjoyed this video. I certainly had fun implementing it. It was fun to see this visual aspect of programming, or like the visual aspect of what I programmed, to see it come back. And yeah, thank you for watching.